Welcome to Spring LIB.
Hi, this problem continues from the previous problem. So we have a piston at point D. If you want more details, you can go to the previous problem as well. And at point D, we have a piston which is in straight line with a point A. And from point A, you have a crank AB of length B equals 60 millimeters. And this point D is connected to this crank. And obviously the piston is restricted to move vertical because of this cylinder. And the vertical angle is theta. So in the previous problem, we already solved for theta equals 0 and theta equals 90 degrees. And just to remind you, at theta equals 0, we found Vd was 0. And at theta equals 90, we found omega Bd was 0 and Vd was non-zero. And we figured out the values. So please check out the previous problem for these cases, analysis of these cases. So here we need to solve it for theta equals 60 degrees. The length of rod Bd is 60 millimeters and the angular velocity of crank AB is 1000 rotations per minute clockwise. Now, like any other problem in this chapter, we break the motion into translation and rotation. And so let's look at the motion of point B. What is the velocity of point B? Because that velocity will be shared by all points because it's a rigid body. So let's draw the rod which we want to analyze. This is our rod BD. At point B, the velocity will come from, the velocity is going to come from this AB. So the angles are given. So this angle is 60 degrees and we know that this length is 60 millimeters and this length we know is 160 millimeters. Anyways, what will be the velocity at this point? So the velocity at this point will be due to the circular motion and it will point along the tangent. So it will point something like here and the value will be omega A times B. And what will be the angle? Since this is 60 degrees from vertical, this angle is going to be 30 degrees. So similarly at point D, from 30 degrees from vertical, we will have a velocity parallel. This will be omega A B. This is the translational velocity. That's why at all the points we have the same velocity. So I haven't drawn it in a most perfectly parallel way. So let me just, so if this is our rod, it's going to be exactly the same velocity as at B. So omega A B. And the angle from vertical is going to be 30 degrees as we figured out. Okay, this is the translational part. Now let's write down the rotational part. So for rotational part, this is our rod. I draw pretty fat rods. I should make my rods dyed so that they are slightly thin. It's hard to draw the correct angles with these fat rods. But anyways, so for rotational motion, we assume B to be fixed. And at point D, let us assume anti-clockwise motion this time. So as I said, this doesn't matter. You can assume clockwise or anti-clockwise. Eventually, if your motion was the other way around, you will get a negative number. So negative of that direction means the other direction. So you will always get the correct answer. Anyways, so at point D, if the angular motion is like this, then the velocity due to omega BDL, which is the radial velocity for angular motion omega BD, is going to point at 90 degrees. And what will be this angle? So this angle was 60. So what is the angle of B from the vertical or horizontal? So if this angle was 60, this angle has to be 30, then this angle has to be 60. So it's 60 degrees from the horizontal, our rod B. So let's just continue. So this angle is 60. And since this is perpendicular to rod B, this angle has to be 30 degrees. Okay, now we know that the net motion at point D has to be along vertical, and at point B it's just the radial component omega A B because of the motion of the crank. So for having this kind of net motion, like in previous part, we know that the horizontal components have to cancel. So this component, which is omega B D L cosine 30, has to equal this component, which will be omega A B sine 30. So we get equation omega A times B sine 30 equals, let me write this B cleanly, it looks dirty. Pen battery is low. Anyways, I think I'll finish this. So omega A B sine 30 equals omega BD L cos 30. So omega BD is omega A B sine 30 is half, and cos 30 is square root 3 over 2, so they cancel, and here we'll get L. So omega A B over root 3 L. We put the numbers in. This will be 1000 times 6.28 radians per 60 seconds. B will be 60 millimeters. This will be 160, L will be 160 millimeters. This is radians, this is seconds already. So always check your units. If you followed me, I catch my mistakes many times just because I check the units. So 60 cancels, 0 cancels. This is 8. Actually, yeah, and this is 3.14. Then this is 2, this is 25. So 25 fours are 100, 25 1 is 25 plus 10, 35. Point 25 threes are 75 plus 3, 78.50 divided by 2 radians per second, and no change of direction, so no minus sign, so it's going to be anti-clockwise. So the final answer will be 34.25 radians per second anti-clockwise. Now what about VD? Now VD from our diagram is going to come from the sum of the vertical components. So the vertical components in this direction is going to be omega A B for the translational part, omega A B cosine 30, and then for the rotational part, this is also going to point down. So since this was 30, this will be omega BD L sine 30. So they both will add because they are both pointing downwards. So oops, yeah. So let's write down VD. VD is omega A B sine 30 plus omega BD L sine 30. I think this was cos 30. Let me just check quickly. Yeah, omega A B L cos 30, and this was sine 30. And now we know all these values, so we just plug those values in. So omega A is 1000 times 6.28 divided by multiplied by 60 millimeters divided by 60 seconds times 160 millimeters. This is finally getting everything. Oh, there is no length here, so yeah, only millimeters per second. Again, as I said, check the units, you will catch your mistakes. So millimeters per second plus omega BD is 34.25 times length is 160 millimeters. Sine 30 is half and cos 30 is root 3 over 2. So this is half, and here we have square root 3 over 2. 60 cancels 60, and 2 cancels this, we get 80 here. 2 cancels this, we get 500 here, or I think it was easier to multiply and then divide, but anyways, so right, and square root 3 is 1.73. So let's simplify this further. So 5 8s are 40, 5 2s are 10 plus 4 14, 5 6 are 30 plus 131. 40 times 1.73 millimeters per second, plus this will be 8 5s are 40, 8 2s are 16 plus 4 20, then 8 4s are 16, 8 4s are 32 plus 2 34, and then 8 3s are 23 plus 3 26 264. Yeah, that makes sense. And then yeah, so this much plus this much also millimeters per second, because this was radians per second. So this number is finally 3140 times 1.73. Let's calculate. 3140 times 1.73. So 3140 times 1.73, that's 5432.2. So 5432.2 plus 264 millimeters per second. So this will be 0.2, 246, 369, 426, 5696.2 millimeters per second, or 5.7 meters per second. This will be velocity of d, and this will be pointing downwards from our diagram. So we have figured out both omega bd and vd. So all these problems are simple. You just need to break it down into translation and rotation, correctly add the velocities. That's all. See you in the next problem.